Namaste ma'am, I am Asha. I am from First Biotechnology and my group members are Dhanadevi and Joshna. Now I am going to explain the topic defects in crystals. If the constituent particles, atoms or ions or molecules in a crystal are arranged in a regular pattern, then the crystal is called ideal or perfect structure. If any crystal deviates from ideal crystal of periodic arrangement, its constituents is called crystal defect or imperfection of crystal. There are two types of crystals. They are point defects and line defects. First, point defects. It is due to missing of atoms, displaced atoms or extra atoms in the crystal. It is further classified into two types. They are defects in stoichiometric compounds and defects in non-stoichiometric compounds. First, defects in stoichiometric compounds. The crystals in which the number of cations and anions are exactly in the same ratio indicated by their chemical formula. In stoichiometric compounds, two defects are observed. They are Schottky defects and Frankel defect. Schottky defect. This defect was first observed by the German scientist Schottky in 1930. In this defect, equal number of cations and anions are missing from their lattice site and forms equal number of cationic and anionic vacancies or holes, and also the crystal maintains electrical neutrality. This type of defect is observed in strongly ionic compounds with a high coordination number. The cation and anion having similar in size. Example, NaCl, KCl, KBr, CSCl, AgBr, etc. Consequences of Schottky defects. The density of crystalline solids decreases, lattice energy and thereby stability of the crystalline solid decreases, entropy increases. Frankel defect. This defect was discovered and studied by a Russian scientist Frankel in the year 1926. This defect is arised due to some of the ions. They are cations missing from their lattice position and occupy interstitial sites. It is also called as dislocation defect. This type of defect occurs in compounds having low coordination number, compounds having ions of different sizes, that is, anion having large size than cation, compounds having high polarizable anions and cations. Next, example of this defect is mainly found in transition metal halides like AgCl, AgBr, AgI and ZnS. This type of defect leads to an increase in the dielectric constant of the medium. AgBr shows both Frankel and Schottky defect. Defects in non-stoichiometric compounds. The compounds in which the number of positive and negative ions are not exactly in the ratio as indicated by their chemical formula are called as non-stoichiometric compounds. These are also known as Berthollet compounds. Examples: in FeO, ratio of positive and negative ions is 0:94:1. Vanadium oxide has non-stoichiometric formula VOX, where X lies between 0.6 and 1.3. ZnY exists as a non-stoichiometric compounds having excess of zinc. In a crystal, if positive particles are excess, the charge is balanced by the presence of extra electrons. If negative particles are in excess, the charge is balanced by acquiring higher oxidation state by the metal atoms. Non-stoichiometric defects are of two types. They are metal excess defect and non-metal excess defect. Metal excess defect. This type of defect may arise in two ways. Anion vacancies. A negative ion may be missing from its lattice site, leaving behind a vacancy or hole. This vacancy or hole is occupied by an extra electron to maintain electrical neutrality. This defect is seen somewhat similar to Schottky defect. This is the diagrammatic view. Metal excess due to anion vacancy defect. Metal excess due to presence of interstitial cation. Example of anion vacancies. Anion vacancies in alkali metal halides are produced by heating the metal halides in the atmosphere to alkali metal vapors. When NaCl is treated with sodium vapor, a yellow form of NaCl is obtained which has excess of sodium ions. Non-stoichiometric. Potassium chloride with excess of potassium is violet. Non-stoichiometric LaCl with excess of lithium is pink. Extra cation occupying the interstitial site. It involves the presence of extra cation occupying in interstitial site in order to maintain electrical neutrality. Electrons are also present in interstitial position. This defect is similar to Frankel defect. When ZnO is heated, it loses oxygen and turns yellow. Metal deficiency defect. This type of defect may arise in two ways. Cation vacancies. In this type, a positive ion is missing from its lattice site and the charge is balanced by the oxidation of some cations to higher valency state. Example, FeO, NiO and TiO. Metal deficiency defect due to anion vacancy. Metal deficiency defect due to defect caused by interstitial negative ion. Extra anion occupying the interstitial sites. This type of defect involves the presence of an extra cation in an interstitial position. In order to maintain electrical neutrality, the cation undergo higher oxidation state. Thank you.